My name is Tobias Nyholm. I'm going to talk about state machines. This is my Twitter handle if you want to see me on Twitter. And the reason why I want to talk about state machines is I believe that web developers only care about echoing out HTML. And I want to show that it's more to development than just printing stuff really, really fast. So I want to introduce some fun patterns or algorithms for you. And I didn't really bring any state machine with me. I don't have any in my pocket or something. It's not really a thing. It's just something that holds state. It could be like a traffic light. It could be the small lights on your washer, or it could be state of a pull request. So it's more of a way of thinking than an actual thing. This slide has a lot of text. It's basically photograph the slide and show it to the manager whenever, Short about me, I work at a company called Happier. We're matching companies and people to match together on soft skills. I do a lot of Symfony stuff, and I do running PHP meetups in Stockholm, and I'm doing plenty of open source. I started my open source career in 2015 when the PSR6 came out, and I wrote an implementation for the cache. Same time I started involved in a project called HP Plug, which is an abstraction over HP client, like Guzzle. And when you're doing HP clients, you want to do API clients, you're doing mail clients, and now I'm maintainer of both Guzzle and Buzz. I'm writing a PSR implementation, I'm writing some standards for Fig, use some geocode stuff, and I do plenty of other things. The most interesting library here is the NSA one. NSA totally violates class privacy. So accessing private properties or private methods is super simple with NSA. It's great for testing. It's barely great for testing, but it's a good library to have sometimes. When I are faced with a new concept or a new thing, I'll try to learn how it really works under the hood. When I was a student driver, I had a real problem working with the clutch. I mean, everybody has this problem. But when I understood what's really happening in the engine when you're pressing the clutch, it makes more sense to me. And it was way easier to operate the car. Even though I can't really build a car myself, it's simpler to understand how to operate the car if you understand how it works. And so this is pretty much what I want to do today. I want to start with small examples and then use the real thing. Does it make sense? So this is a super simple state machine. Like I said, a state machine is just something that holds states. So here I defined 3 states, and I've defined how to move between them. Since there's no arrow between red and green, I can't move from red to green. So this is the perfect example of a state machine. You all look super confident, so I guess this is simple for you. How about this? What is this a state machine for? Sometimes we'll ask rhetorical questions. This was not that kind of question. I want to have an answer. A door, perfect. It's elevator doors. There are 4 states. They can be open or closed, or they can be opening or closing. And if you click the open button when they're closing, it interrupts the opening process and starts to... Yes, interrupts the closing operation and starts to open again. Does it make sense? Good. I said I work at a company that matches up people and companies, and we are a tool for recruiting. So we have this kind of state machine. This is a job advert for us. We have defined, or the business requirement has defined, a job advert can only be in these 5 states. It can either be draft, or it can be in review, or it can be in trash. If it has been in review, you publish it. After publish, it will eventually go to the archive. This is something the businessmen wrote down on the whiteboard. Now it's your turn to guess again. Sorry? A pull request, yes. I mean, when you start coding, you start some coding, you submit a pull request, and it could go then Travis starts running, and then it goes to review stage, and hopefully you get some feedback so you can change your code and run the Travis again. You change the code, submit an update, run the Travis again, and there it can either be merged or it can be closed. If it's been closed, it could be reopened again. So this is the way you can think of a pull request. So how do we actually implement this? How can we actually build a state machine for this? Do we have any suggestions how to build a state machine like this?
Some kind of workflow.
Some kind of workflow, yes.
First of all, you have to describe all states.
Sure, we should have a list of states. Maybe we should have a class at first. Class. I mean, I wrote class state machine. And then we should have maybe have places or states. What more should we have? How to make it more state machine more useful? But maybe what more should we have? Transitions, and then you said, yeah, names. This says places or names. Maybe we should have some transitions. Anything else? Maybe we should have some functions to this class as well. Yeah, some sort of action like do stuff thing. Yeah, do stuff. Set state, sure, so to update the set. We should probably have a state here as well, like the current state. I now realized way too late that you probably won't see what I'm writing here, but you have an idea what I wrote here, right? This kind of works. I mean, you have do stuff, you have set state. Do we have anything else on top of our heads? One more time, please. It seems like a core stuff, yeah. I actually cheated, I prepared. I wrote something like this. So you have do stuff, get state, set state. So it's basically what we wrote here as well, which is great. Did any one of you were on the workshop yesterday when Hugo was talking about patterns and stuff? Yeah, he mentioned the state pattern and the more state machine. It's actually a great pattern, as he said. However, this is only a 3-hour workshop. We won't talk about the more state machine. We will talk about something that's more flexible, more cool. We'll talk about the meal state machine. I thought I skipped that slide. Sorry for this. We'll talk about the meal state machine now. And this was a slide I want to kick you off with this. Let's start with meal state machine. Let's start to implement this and try to do like a traffic light. Let's start to implement the traffic light. I mean, this is a good base. I mean, if you like, you can write this in the class yourself or check out that branch on this repository. Also, something important on this, if you check out the branch, do a git pull as well. I'm not sure if you are using the version box or not. But do a git pull because I did some changes this morning. This exercise, this branch has pretty much, I think, 3 exercises and a bonus exercise. And try to make them as simple as possible, like as small as possible, because I don't expect you to like store things in a database and stuff. So try to make them as small as possible. So the first exercise will basically be like, hey, let's try to create a state machine that looks like this, and implement that somehow. So we can make sure we can't really move to the red light if you're in the green light. The README of this branch explains everything way better. So if you didn't understand what I said, just look at the README. Have all of you found this repository, checked out this branch? Good. This is probably what I will do for a while. I will talk a little bit and I'll kick some exercises into you and you for work for a while. Because I believe it's, like I said, it's easier to learn if you write yourself. If you have any questions, just raise your hand and I'll be walking around and help you. After this exercise, I will talk for a while again and then we introduce some other things. And you will work. I hope that's a fair concept. Because just me talking here, I mean, sure, I like to talk, but I know you also like to learn. I should also say that it's 3 exercises and 1 bonus exercise. The 3 normal exercises, they have tests to them. So you can actually, for the first exercise, you can actually just run the test to make sure it works. And for I think for test 2, test 3 and test 4, I think the name of that, you may have to modify the test a little bit. And it's 3 branches, mainly 1, 2, 3. Or maybe 1, 3, 4, I don't remember. If you've done the first exercise and you still wanna, and you're not happy with the implementation somehow, you can just check out the next branch and continue with my code. It's also super fair to just have a sneak peek on my code and then go back to your code. I mean, you are allowed to cheat. Obviously, you're allowed to cheat. This is not a test. This is about learning. And if you feel like cheating, you cheat. And the README will say how you run the test and stuff. It's basically a PHP unit. I see that some of you have come a really long way with exercise 1. Some of you also done with exercise 1. Feel free to start with exercise 2. And if you've done with exercise 2, feel free to start with exercise 3. And then you go back to the bonus exercise if you like. If you're done with exercise 1, you notice that the state machine, or you all have noticed that the state machine has a state itself. It can be tricky for you, if there was a real application, it could be tricky for you to save the state machine to the database. You have another object to save because you want the state machine, in this scenario you have the state machine actually holds the state. In exercise 2, we're trying to work around this to remove the state from the state machine. So in some case the state machine is stateless, which is weird to say, but you move the state machine to another object, like a traffic light object. So that's pretty much exercise 2, to make the state machine reusable for all kinds of traffic lights. I see that most of you are doing very, very well, very fine. So exercise 1 was basically 1 state machine per object. Exercise 2, you can use the same traffic light state machine for multiple traffic light objects, because your state is in the traffic light object again. Exercise 3 now will remove the traffic light logic from the state machine. So you will have like a generic state machine logic, a state machine object. Make sense? So you remove all the transition logic you have in can and apply methods and move that to somewhere else. Maybe you give that state machine object that the definition in the constructor argument. The goal here is to be able to reuse your state machine for all kinds of definitions. Instead of a traffic light state machine, you can have a pull request state machine or any state machine. Does it make sense? You're all really coding really fast, which is excellent. I know some of you have done all exercises. Some of you are still working with the second and third exercises. You feel free to keep working with this. I'm just gonna show you some hints. What I did, I created a state machine class, and I had the private property transitions, and which I get from a constructor somehow. This is basically my transitions, and I've decided that we should have a from state as the key, and then an array in there with the transition name and the to state. This is, I mean, I've seen some of you have done some other definitions or structure of this, but this is just how I did it. And with this clever, transition array, I can use, my can function is pretty simple. I can get the state from the object, and I can just do, does this really exist in this array? That's pretty much what I'm doing. And apply, I'm just checking, can I do this? If I can do this, just apply it, just update the state. And I don't know how many of you did the fourth exercise. Did anyone complete the fourth exercise? Some of you. How many completed the third exercise? With more of you. Okay, fair. The fourth exercise is pretty simple. It's just return. I didn't even write them here. They're not that simple, but you just here you get current state. You just say object get state. That's pretty much it. And the get value transition is basically looking at the transitions array, no matter how you define it. I'm gonna go back to my presentation. If I can figure out how to edit this. How well did we understand this? Even though we didn't all do all four exercises, did we understand what we were doing? Did we feel that it was simple? Relative simple? Excellent. Because we've been working for like 45 minutes doing this. And this was the mealy state machine. The more state machine use state pattern, they have way more objects. They have one object for each state, as you may or may not know. And now the mealy state machine feels more PHP and not like Java. And can I tell you a secret about what we just did? What we just did, we wrote the workflow component. The Symfony workflow component is not much more complicated than what you just did. So this is what I said about small examples. Now we know how it works, but obviously the workflow component has more edge cases and they had more weird stuff and it dispatches events all the time. But in its core, we did exactly the workflow component. And first off, I think it's pretty sweet that we could do this in such a short time. And also think it's pretty sweet that the component is so simple. That's actually what I used to do. I work with the Symfony core team a little bit, and I do some contributions. When I specialize in the easy components, like the messenger components, the workflow component, and the bootstrap form theme, the easy stuff. Now that other smart people handle this complicated stuff. Anyhow, to show off the workflow component, I'll go back to this slide again with my job advert. And if I mark the current event with current state with the red circle, if I'm going to do strict workflow component, I'm getting the workflow from the container somehow, and then I can get a marking store and dump the current places I am in. A marking store is a bit more complicated because it supports multiple states, but it's basically this object return state, get state as I wrote. And if I'm here, I can ask, can I do publish? Or can I do to review? And if I apply, I just move the state. And from here I can apply trash and unpublish. No, trash and untrash. And then I can go to review again. And from review, I can check what's the valid transitions I can do right here. All these functions we implemented just now. And the Symfony workflow component also supports the very same thing, but in Twig. So you can write something like this. This is actually, imagine at my company, you can write adverts or blog posts or whatever. And imagine I have like the WordPress edit page. So I have a big screen where you can write the things. And in the sidebar, you have like publish, trash, or send to review or stuff like that. And this is actually the code for that sidebar. If the workflow is in a state when I can publish, then show the publish link. If it's in a state that I can trash it, show the trash link. So the same sidebar renders differently depending on what state my blog post or my advert is. And you might wonder, if we would create this state machine, why is it called the workflow component, not state machine component? Because that's not the truth. Some people understand what state machine is. It's a small difference. A state machine, this is two transitions in a state machine. If you are in state A, you can either do T1 or T2 to get to the new state. That seems pretty fair. Notice that the transition has only one input and one output. That's true only in a state machine. In a workflow, however, you can do a transition and turn up in 2 different places. So in a workflow, it can be 2 different places at once. And it seems weird, but it kind of makes sense. Because let's look at an example. I stole this example. It's a blog post. And before you publish a blog post, you gotta have an approval from a spell checker and from a journalist. So what I'm doing here, I'm writing the blog post, I'm in draft, and then I want to request a review. And I request a review, and I'm both waiting for the spell checker and the journalist. I don't care which one goes first, I'm waiting for both of them. And the spell checker is probably automatic, so it goes quicker. And here I can't publish. If I ask can I publish, I can't, because publish requires 2 inputs, and I only have 1 input. So I can only publish if I get an approval from journalists, and then I can publish. Did you get it? As a workflow can be in 2 places at once, and you can have workflows like this, you parallelize like this. A workflow rarely contains loops, because it's a workflow. I mean, you do something from A to B, like there's a process. A state machine, however, like a traffic light, it just holds the states. I mean, it's often it contains loops. I usually get asked, when should I use a state machine and when should I use a workflow? And truth is, it doesn't really matter. I mean, only that it's important that you know what object you're dealing with. And also, generally you, not only you. It's important that everybody knows what the state you're dealing with. I have decided in my application I'm only doing state machine because of simplicity. Workflows, sure, makes more sense if you have something like this, if you have a process like this, and decide to only use workflow. That doesn't really care, but you should know what you're dealing with. I also get the question, is it worth using a workflow if I only have 3 states, or a state machine if I only have 3 states? And if you're sure you never have added states, and this code is pretty simple, sure, do whatever. I kind of like using states because I know the code's always correct. Now when we all know how to build a state machine, I would like you to try using a state machine. And I know it's like 50 minutes until the break, but please check this out. It's a new repository, it's a new branch, and there's like 7 exercises. The first 2 is basically try to configure this. If you start with a PHP, you can recognize some things, and then you do it with a way simpler YAML. If you have been working a little bit with state machines before, it might be easy, the first 3 exercises. And then we're going to start focusing on identifying state machines, like refactor code and see where they're useful. So either you do this now, or you continue working with your implementation of state machine from the Mealy state machine. And after the break, we'll all do this. I will let you work now, and I will tell you when the break starts and stops. I threw into a brand new Symfony branch, and I didn't ask, like, are you comfortable working with Symfony? Have you been seeing Symfony before? And the reason why I chose Symfony is basically because I believe Symfony is the coolest and the bestest. I mean, there's plenty of state machine implementations. They all work pretty much the same. So, I mean, if you dislike Symfony for some weird reason, you could use whatever you like. But for this workshop, please bear with me. I'm also using Symfony 4.1 to have this test project. Are you comfortable with Symfony? Have you seen it before? Pretty much all of you. Good. Good. If you haven't, I mean, I'm happy to help with even Symfony-related stuff. It should, because I'm prepared, it should be just to follow the README. You have the commands you need and stuff. And all the code you need is in SRC folder. It shouldn't be any surprises. There will be a break in 5 minutes. Feel free to take a break now if you like. I'll be around here most of the break, so if any one of you will stay in and code here, I'm happy to answer questions or pair program or whatever you like. But feel free to go to a break. We will officially start again at 15:40. And when we officially start, I think I will start to be talking a little about events. We'll see how far you come. But feel free to grab grab a glass of coffee or a mug of coffee glass used before everyone else. So, like I said, without the microphone, I expect you all to work with exercise 1, 2, or 3. Maybe you start with 4. The fourth exercise, no, I'll stay like this instead. The Symfony Workflow component, starting over again. Components in Symfony are very decoupled, and how they can be decoupled like that is because they use the event dispatcher. So basically, one component dispatches an event that another component listens to. So there's no direct dependency. And the workflow component is no different. It dispatches events, and it dispatches a lot of events. I think every time you do a transition, like you do go from A to B, you dispatch like 21 events, which is a lot. And events are, I think it's 7 groups of events. And look at the first 3 ones. So whenever you leave a transition, you have an event. So you have workflow leave. And if you want to be more specific, you have workflow traffic light leave, like whenever you leave something from traffic light. You can also have workflow traffic light leave yellow. That's the third event. And you have events for leaving, you have events for entering, you have events for when you entered, you have events when you complete, and when you are really complete, you announce that you've done a transition. So you have, did I forget anything? Yeah, and also have an event for when you're actually doing the transition. So we have plenty of events, and at the first version of this component only had 3 types of events, like enter, leave, and transition, maybe announce as well. But I carefully reviewed all the pull requests that added more events, and they make sense. Some pull requests have something to do with when doctrine flushes or persists things. Anyhow, that's why it's both entered, and completed. You don't need to bother about all of them if you don't have specific use cases. But I want to say these events are excellent to hook into. These events are excellent for, like exercise 4, I want you to create an event listener that logs every transaction. Or maybe just logs transaction that goes to red. And it's also great to hook into your domain logic. Like, I totally have the workflow for adverts, and when an advert is published, I probably want to say an email saying thank you for your order or something, or email all the users that may be interested in the advert. So I'm using these events to hook into my domain logic, which is great because I know, because I implement state machines, I know no advert will ever be published unless the workflow job title announce has been fired. You get me? I always know that event will be fired when an advert is published. So these are great to hook into your domain logic. So if you're ready for exercise 4, please try to write an event subscriber that handle this, that listens to any of these events, and do something simple, just log things. If you get an error like this, neither property marking nor one of the methods get marking, is marking, has marking, or get exist in a public class. Some of you have seen this. It's not a mistake by me. I wanted you to get this error to realize, hey, I maybe should do something. And in the documentation, I see that I have something called marking store, which is basically an abstraction that helps you interact with the state traffic light object in this case. So actually, the marking store extracts some data, like set state, get state. This is pretty much what the marking store does. So we're going to tell the marking store it could either be multiple state, like in a workflow, or in a single state, like in a state machine. And we had to tell them that the property name default is marking. Here in this example is current place. But we want to copy this and add a single state marking store, and we want to have it state. Oh sorry, did you see this? Did you see what I'm doing? I just added this few lines. So when I do this, I don't get this error anymore because the marking store knows that I want to go to state. And this state is a property of the traffic light. That's the property. And since I didn't have any marking property, that's why I got this error. I want to interrupt you even more and talk about events again. I know some of you started, maybe some of you finished with the event listener and logging. There's actually more events than what I just showed you, these 21, is 3 extra guard events, which you could control the flow. With a guard event, you can say, I mean, that transition, currently you have a transition from A to B, and if there's a transition, you can apply it. But a guard event can add some extra logic here. So in a guard event listener, you can say that you can block a transition if some external condition. So say you have a business rule saying you cannot publish a blog post unless it's between 5 and 6 in the afternoon. Or you can't publish a blog post at lunch. That's where you use guard events. And I think exercise 5 says, please use a guard event to make sure only an admin can make your statement, the traffic light, red. And I don't know if you noticed, I know that some of you fired up the web interface and clicked around. In the top right corner, there's a login as. You can log in as the subscriber or journalist or user and an admin. So implement a guard event and make sure that only admin can click on a 2 red button. And as normal, you can just skip this exercise if you don't like it, or you can continue working with the premium exercises. Raise your hand if you'd like me to come around and help you with something. In a few minutes, I will show you one solution to the web subscribers, and then I'll show you some other examples. Then I kick off the next exercise. Most of you are done with the event dispatch already. And since you are all experienced Symfony developers, or it seems like it, you know that you write an event to subscriber something like this. And it's basically just injecting the logger, and you can you basically inject the logger and you do whatever. The event here is not the standard Symfony event. It's actually a special event that only live in the workflow component. So the event, on this event you have, you can see the use case, the third line up there. In this event you have something like get subject and get transition and stuff, which it's just helper classes. And when you're finishing up the guard event, as you're doing it right now, you get a guard event back, which has a function called set blocked. So you can actually block a transition with a guard event. I'll give you a few minutes to finish that, and I'll show you my solution. Then I kick off with the pull request exercise. I know that some of you haven't completed this yet. I know some haven't completed this yet, but I'll still want to push a little bit forward. And it's okay. I mean, I know that most of you won't do it all exercises, and that's fine. I mean, the repository will be here forever. You can do it at the next week if you like to, or never if you don't care. This is the normal event subscriber. The guard event is pretty much the same. I'm still listening to an event. It's called Workflow Job Advert Guard Publish in my case. And I'm using a service called Authorization Checker that I can check if this user has the correct role to do this action. Are you familiar with the Symfony security system? There is a concept of voters. So you can actually vote if this, you can implement your own logic to make sure things are allowed or not. So again, in my application, I have a lot of job adverts, and sometimes the job advert is allowed to be seen for the public, right? Only if you publish it, not when the job advert is in draft. You're not about to see it. So I implement a security voter using the state machine states. So I'm going to check if someone requests to view a job advert. I'm checking, does this job advert is this job advert in the state published? If it is, I grant access. This is a way I can use the state machine in my other logic, or in my other business logic. And here's another. I mean, I mentioned this before. You can use these events on your domain logic. Whenever something is published, I tell the world. For the remaining time we have now, it's about 30-35 minutes. Either you continue working or you continue with the next exercise. There's 2 more exercises. First is about the pull request. I'd like you to see and try to identify where to use a state machine. I mean, when I used to write code like this. This is basically a state machine with only states, no transitions. And when you see this, it's a good sign like, hey, maybe I should use a state machine here. I also write a lot of code like this. This is actually a real example from before using state machines. I'm like, I have a booleans for, is this job advert open? Is this job advert closed? Is this job advert archived? Or maybe I have closed and ended. So many hours I spent to figure out what's the difference between closed and ended. So if you have multiple booleans like this, it's also, yeah, this is a good idea to introduce a state machine. So what I've done here, the next exercise 5 or 6, the pull request exercise 6, I basically added some legacy code or code without state machines. And I wanted to look at the class and try to figure out what's happening. And just try to write, because there is a state machine under there somehow, and try to write it down on a piece of paper what is actually happening. And if you have time and feel like it, please refactor this to use a state machine and see how easy it is to make changes when you actually have a state machine. I will also introduce the next exercise at the same time, and you can pick and choose which one you would like to do first. Say there's a business requirement that whenever users sign up, it has to go between four steps, like 4-step form. So first the user has to add their name, they click next, and then you have to add their email, click next, and then maybe the favorite color and click next, and maybe a Twitter handle. So you want to have a you gotta have a form like this, and you have all form actions, and they redirect to each other, just stuff like that. What if the business requirement says that you should change the order? That's a hassle, especially if you have a longer than 4-step form. But using a state machine, it's easy, it makes more sense because you only change the configuration. The last exercise is that a bunch of legacy code, and you should slap on a state machine on that legacy code that looks like this. And I want you also to implement some more security, because in the legacy example, I could go to start page, like go to the start of this flow, add my name, and then just hack the URLs because you get to the 3rd state or the 4th state, right? I can just guess the URLs. I want you to introduce some protection against that. And if you want to have a golden star, you can make sure that if I want to change the order, I only change my configuration and never touch my controllers or twig. Does it make sense? If you want to, I can show you the solution to these in the very end. I can show you my solution, not the solution. My solution is in the very end. But this is 2 more exercises. It's about 30 minutes left, so you pick and choose which one you want to do, or do both if you're super duper quick. I will start to wrap things up now. It's almost time for the ending keynote over there. I will just show you these 2 private functions. This is the multi-step form. One is used for verify that I'm actually in the state I think I am in. So when you're in an email state, when you're an email controller, it says verify that I'm in email state. If not, redirect me to the state I really am in. So that's how you protect you from cheating. And you also, when you submitted a form and you saved it to the data to the database, you can have the or what they call it, get the next step redirect. So make sure to redirect you. Those 2 functions are pretty similar, but it's just an idea how to use the metadata store for grabbing metadata. I also get a question that you could use form validation groups. Like the user object, you can have different validation groups depending on different states. So make sure your form validates properly, your objects validates properly. We've been working for almost 3 hours. Most of you worked through the break. And we have built our own state machine. We have learned to configure it with Symfony, both with PHP and YAML. We know the difference between a state machine and a workflow. We have created event subscribers. We have created guards. And we have tried to refactor some legacy code. And we have learned to identify where to use the state machine, how to use the state machine. So I'm happy to leave you with this, like, hey, you all know your state machines now. I mean, from now on, it's just to practice, practice, practice. You just try to refactor as much code as possible and start writing this. Because, I mean, you are out of my training. Thank you for participating and listening so long.